Units of measurement. A unit of measurement is what accompanies a quantitative observation. If you recall, a quantitative observation is a numerical observation. So it's any observation that involves numbers. For example, if I were to measure the height of a tree, I might see that it's 2.8 meters, okay? Now, if I said the tree was green, that would be a qualitative observation because that's not involving numbers, but I'm using a quantitative observation. It's height, right? So I'm saying that it's 2.8 meters. Now, with each quantitative observation, it is always accompanied by a measurement, okay? I'm measuring how tall the tree is. And with each measurement, it must consist of two things. It consists of a number portion, that is the 2.8 over here, and it consists of a scale, or the unit, and that's the meters over here. The meters tells us how big the tree really is. If I only said 2.8, you would have no idea how tall the tree is. It could be 2.8 meters. Is it 2.8 feet? Is it 2.8 kilometers? No one knows. It's the unit that tells us the scale of the number. Okay, so each measurement must have a number and a scale. The reason we do this is so that we can standardize the units, so scientists from around the world can easily communicate. If everyone had different units from all different parts of the globe, that would be really confusing. No, you might have random units like I don't know. One scientist might have a meter that's the size of a school bus, and another scientist might have a meter that's the size of a penny, right? So we have to standardize units such that everyone from around the world can easily communicate. This standardization is achieved through the International System of Units. It's based on the metric system, and the reason is it's usually abbreviated as SI units. The reason it's SI units is because in French it's the Système International. I don't know if I'm pronouncing that right, but let's see. Okay, all other units are derived from SI units. So these are the 7 basic SI units, the fundamental SI units, and all other units that you find that's not on this table are derived from these fundamental units. What do I mean by that? Let's take volume as an example. Volume is not a fundamental SI unit. Instead, it uses the fundamental unit length to get where it's from. Okay, so volume is just length cubed, right? The length portion is part of the standard SI units. And that's how we get all our units, whether it's newtons, whether it's pressure. For example, pressure is measured in pascals, okay? But pascals is really just force over area, and force is derived from the SI units, and so is area. Area would be length squared, right? So all units you find in chemistry, in physics, in all the sciences will be derived from these fundamental 7 SI units. Prefixes. So not all fundamental SI units are easy to work with. For example, length is in meters, right? What if I wanted to measure the distance from my house to the nearest supermarket? Probably draw, I know, chicken wing here. Okay. What if you want to measure that? You don't want to say, 4,500 meters, right? That's a little bit too large of a number. So instead, you might say kilometers, 4.5 kilometers. And if you go the kilometer, the kilo in front of the meter signals that it's 1,000 meters. So 4.5 kilometers, this case signals that it's 4,500 meters, okay? Because if you go to the table of prefixes, you can see a kilo is 1,000, right? So 4.5 kilometers is 4,500 meters. Same thing with seconds, right? So for example, if we wanted to measure something really fast, it might happen in 0.03 of a second, right? And we don't really want to work with these decimal places. So instead, we might change it to milli. Milli would be 10 to the negative 3, so 0.001 seconds. That's how we can essentially change my bad, change fundamental units to be much easier to work with. And this includes non-fundamental units as well. You could say millinewtons, you could say gigawatts, all sort of things.